Consider subscribing. This channel focuses on how ammunition actually behaves once it leaves the muzzle. Let's start with a .22 long rifle load that changed expectations about what rimfire penetration could look like. 1. CCI Velociter 40 grain hollow point 22 LR. The CCI Velociter represents a different approach to rimfire performance. Instead of chasing extreme velocity with lightweight bullets, it maintains a heavier 40 grain projectile while pushing it to elevated velocities. Heavier bullet mass increases momentum, improves penetration consistency. At the same time, the higher velocity compared to traditional standard loads enhances expansion reliability. Many hollow point .22 loads struggle with inconsistent expansion, especially when fired from shorter barrels. The Velociter was engineered to address that problem. It maintains enough impact speed to encourage expansion while still retaining the structural integrity needed for deeper penetration than lightweight, hypervelocity rounds. In practical field use, it demonstrates a rare combination for rimfire, reliable expansion without sacrificing straight-line penetration. That balance is what allows it to perform noticeably above what many expect from .22 LR. The key lesson here is simple. Weight and velocity must work together. Too light and penetration suffers. Too slow and expansion fails. The Velociter sits in that narrow performance window effectively. But not all high-performance rimfire loads rely on expansion. Some prioritize penetration above everything else. 2. Federal Punch 29 grain flat nose 22 LR. The Federal Punch approaches rimfire design from a different philosophy: penetration above everything else. 2. Federal Punch 29 grain flat nose 22 LR. The Federal Punch approaches rimfire design from a different philosophy. Instead of focusing on mushrooming expansion, it emphasizes consistent penetration through a solid flat nose design. The flat nose profile creates a more effective impact surface compared to traditional round nose bullets. Rather than slipping through tissue with minimal disruption, it transfers energy more directly while maintaining its structural integrity. Because rimfire cartridges operate within limited energy ranges, bullet design becomes more important than raw speed. The punch load recognizes that reality. It avoids aggressive hollow point cavities that may collapse inconsistently at lower impact velocities. Instead, it focuses on maintaining a straight, predictable path. In ballistic testing, flat-nose rimfire bullets frequently demonstrate more stable penetration. They resist early fragmentation. They resist unpredictable deflection. That consistency is what separates it from generic rimfire loads. The surprising truth about rimfire is that penetration is often more dependent on bullet profile, and this load proves that. However, when stepping up to Magnum rimfire, velocity once again changes the equation. 3. Hornady VMAX 30 grain 22 Magnum. The .22 Winchester Magnum rimfire operates in a completely different performance class than standard .22 LR. With velocities often exceeding 2,000 feet per second from rifle barrels, it significantly expands the ballistic envelope. Hornady's 30 grain VMAX takes advantage of that velocity through polymer-tipped bullet design. The polymer tip initiates rapid expansion upon impact. At Magnum rimfire speeds, this expansion can be dramatic. Unlike traditional soft lead bullets, the VMAX is engineered for controlled but aggressive fragmentation in small game application. It maximizes energy transfer quickly. In practical use, this produces highly effective terminal performance on varmints within appropriate distances. The lighter bullet weight also contributes to flatter trajectory compared to heavier WMR options. Lighter bullets sacrifice some penetration depth in exchange for expansion speed. That trade-off is deliberate. The VMAX is optimized for rapid energy release rather than deep drive-through. What makes this load impressive is not that it is large, it's that it pushes rimfire engineering toward modern bullet technology concepts usually associated with centerfire cartridges. But not all Magnum rimfire performance relies on lightweight bullets. Some loads emphasize penetration stability instead of rapid fragmentation. Or Winchester Super X 40 grain JHP 22 Magnum. While lightweight polymer-tipped rounds draw attention, The 40-grain jacketed hollow point in .22 Magnum demonstrates a more balanced approach. The heavier bullet retains momentum better than 30-grain alternatives. That increased mass promotes deeper penetration while still allowing expansion at magnum velocities. Instead of fragmenting aggressively, it expands more traditionally. The bullet deforms while maintaining enough structure to continue penetrating. That balance makes it highly versatile within the rimfire magnum category. It does not depend entirely on speed for effect. It combines weight and velocity to create predictable results. The difference between lightweight and heavier magnum rimfire bullets highlights an important lesson. Rimfire performance is not defined solely by velocity. It is defined by how bullet mass interacts with impact speed. And when discussing velocity-driven rimfire loads, one name always resurfaces. 5. CCI Stinger 32-grain hypervelocity 22 LR. The CCI Stinger has long been one of the most recognized hypervelocity 22 LR loads. By using a lighter 32-grain bullet and a slightly extended case design, it achieves velocities significantly higher than standard .22 LR offerings. From rifle barrels, it can exceed 1,600 feet per second. That increase in speed reduces bullet drop at moderate distances and increases expansion potential on impact. However, lighter bullets inherently reduce penetration compared to heavier 40-grain loads. The Stinger trades depth for speed. That trade-off must be understood. In applications where rapid expansion and flatter trajectory are desirable, it performs impressively within rimfire limits, but it also demonstrates the delicate balance of rimfire engineering. Pushing velocity higher narrows the margin for penetration. The Stinger illustrates how rimfire loads can maximize speed, but it also reinforces that velocity alone does not define effectiveness. The bigger reality about rimfire performance. Rimfire cartridges operate in a narrow ballistic window. That limitation forces manufacturers to optimize carefully. Bullet construction becomes critical. Weight distribution becomes critical. Nose shape becomes critical. Even minor changes in barrel length can significantly affect performance. Unlike centerfire cartridges that often carry excess energy, rimfire loads do not have room for inefficiency. Every design decision matters. That is why certain rimfire loads punch above their weight. They are engineered specifically to maximize performance within rimfire constraints. It is not about comparing rimfire to centerfire. It is about understanding rimfire's intended role and recognizing how modern bullet engineering has improved its effectiveness. Rimfire cartridges are frequently underestimated because of their size, but performance is not defined by diameter alone. Bullet construction determines expansion. Bullet weight determines momentum. Velocity determines impact behavior. The 5 rimfire loads discussed today demonstrate how modern engineering can dramatically influence terminal results, even within limited energy ranges. Understanding those differences allows shooters to make informed decisions instead of relying on assumptions. If you want continued firearm analysis focused on real ballistic behavior instead of surface-level comparisons, subscribe for future breakdowns. Because even the smallest cartridges deserve serious examination. And rimfire still has far more depth than most people realize.